Double angle and half angle. I'm combining these into one video just to speed things along a little bit here. We'll start off with double angle identities and a couple of examples, and then we'll switch to the half angle identities. The double angle identities are used to find an angle by the ratio, or the sine ratio, or sine function of an angle, by first thinking about what we could plug in that would be half of that angle. Usually these answers are already going to be on the unit circle, so we don't use double angle as much. But for example, if I wanted to know the sine of 120, that means that 120 would be my 2u, so that 60 would be what I plug in for u. There are 3 different ways of using the cosine double angle identity. Any of those 3 will work. You might just have a certain preference based on the particular example. If we're being asked to use the double angle identity to find the sine of 60, that means 60 is the 2u, so 30 is the u. That's what we're going to plug in to here and to here. And then we evaluate each piece. 2 and 1/2 cancel out to be 1, and so we get the answer that we would expect from our unit circle. We get the sine of 60 equals root 3 over 2. More often you might be asked to move a little bit backwards. You might see this in a equation you're solving, and we'll do an example like that later. So you'll use your double angle identities to simplify. This first one, u is 10, so 2u equals 20. This one is the double sine identity, so this is the sine of 20 degrees. The second one is one of the cosine identities with a u value of 15, making 2u 30. So we're being asked for the cosine of 30, which we could evaluate. We already know that answer. The last one is the double angle tangent identity, which is asking for the tangent of 100 if u is 50. Half angle identities get used a little bit more often because a lot of these answers won't be on the unit circle. Particularly, you need to have these memorized for calculus. Notice once again that there are 3 options for tangent. Only one of them is under the square root. And a lot of us forgot this on the last quiz, that if you take the square root of something, there's a positive and a negative answer. If we're being asked to find the cosine of 5 pi over 8, that means that u over 2 is 5 pi over 8. I need to know what u is, so I need to know what to plug into our identity. There's the identity up there. Solving for u, I would need to multiply both sides by 2. And I get 10 pi over 8, which reduces to 5 pi over 4. That's what we're going to plug in right here in the identity. So let's rewrite that with everything filled in. And we're going to have to do a lot of work with fractions. So it's lengthy, but the end of it should be fairly easy mathematically. When we evaluate the cosine of 5 pi over 4, we get negative root 2 over 2. So that's why the sign changes. In my next step, I'm going to make the numerator all one fraction by changing the 1 into a 2 over 2. Be careful, we have a lot of fractions going on, and don't forget that there's still a radical over everything. One more step to deal with the fraction, I need to multiply by the reciprocal of the denominator. So I'm making that 2 over 1. So that gives us plus or minus the square root of 2 minus root 2 all over 4. If we can simplify the denominator, if we could take the square root of either the numerator or the denominator, we should do that. And in this case we can, and we get a final answer, plus or minus the square root of 2 minus root 2, that part doesn't change, but the square root of 4 is 2. So lots of 2's, lots of radicals, lots of fractions, but a lot of the answers are going to look similar. This last example, I'm going to get you started on it. I'm not going to go through the whole solving process, but I want to show you where the half-angle identity comes into this. We take this x over 2, the sign of x over 2, and we're going to plug in the half-angle identity for sine. So think, for example, remind yourself that sine squared of x over 2 is the same thing as sine of x over 2 squared. I'm going to plug in all of this in for the sine of x over 2. So that's where we are so far. The next thing that I'm going to do is watch out for the radical and the raising to the second power. Those two are going to cancel out, and that makes the plus or minus not important anymore. Now this is starting to look a little bit more manageable. The 2's cancel out, which leaves us with sine squared x equals 1 minus cosine x. The next thing that I would do is try to change one of those two into the other. So if we can change sine squared x into a cosine term, or vice versa, we want to do that, and then you're going to solve this by factoring a quadratic. That's what you would get right before you factor, and then you could solve it from there. Alright, that's it. Make sure you submit your questions and look at my comments when I submit those to you.